The next few videos will be about proving some identities that may be useful later on as we look for some results of specific examples. Now this time, let's prove that the product of two reflections, the first one is the reflection on the angle or a line, let's say theta, and we have here for phi is equal to the rotation of twice the sum of phi and theta. Let us be guided that the reflection of, let's say, theta will have this form. You have cosine twice theta, sine twice theta, sine twice theta, and negative cosine twice theta. This is when we multiply with the component x sub 1 and x sub 2, but this time let's just focus on this identity here. Similarly, for your rotation, let's just use beta so you will not be confused with the notations later on. But basically, if it's rotation, we don't have twice, so it's just beta. I'm having here beta, sine of beta, here negative sine of beta, and we have here a cosine of beta. Okay, that would be for, again, x sub 1 and x sub 2 if necessary. But then again, let's focus on these two identities and later on show that the product of them, if we're going to change, of course, we can change this to phi, change all of this to phi as well. If their product with the reflection of theta will result to this, or in this form, okay, given that it should be twice alpha theta plus phi. So you will have it here, the proof. So let's have the reflection of theta times the reflection of your phi. So it's a product of two reflections. You have cosine twice theta, sine twice theta, sine twice theta, and negative cosine twice theta. To be multiplied with cosine twice phi, sine twice phi, sine twice phi, and negative cosine twice phi. Okay? So take note, this is defined because when you multiply 2 by 2 by 2 by 2 matrix, the result for that is also a 2 by 2 matrix. Let's show the result for it step by step. Take note that we are going to multiply the first row with the first column to get the first entry here, and then so on and so forth when we talk about matrix multiplication. So you will have here the result, cosine twice theta, cosine twice phi, okay, plus you have sine twice theta, theta, sine twice phi, okay. So let me erase this portion here, or even make this little bit compressed, plus sine twice theta, sine twice phi, okay, because I need to reserve this space for the next result. So this time, this one and this. So we have sine twice theta, cosine twice phi, and plus negative cosine twice theta, sine twice phi. Now, for this and that, you will have here cosine twice theta, sine twice phi, okay, and then you have here plus sine twice theta times this, hopefully this is still enough, cosine twice phi. Okay, the spaces are not enough, hopefully it's already okay with you if I have something like this. So minus cosine twice phi. Okay, now for the last, this one and this, so you will have here sine twice theta, sine twice phi, then you will have plus negative cosine twice theta times negative cosine twice phi. Okay, I did not simplify automatically the, what they call this one, the signs, because I have the next step for that, for step-by-step process. Cosine twice theta, cosine twice phi, plus sine twice theta, sine twice phi. At the bottom, apply here sine twice theta, cosine twice phi, minus, if I'm correct, right? Minus cosine twice theta, sine twice phi. Sorry, that's phi. Next, at the top, you will have here cosine twice theta, sine twice phi, then minus, that's negative times positive, sine twice theta, cosine twice phi. Okay. At the bottom, you will have here sine twice theta, sine twice phi, now positive cosine twice theta, cosine twice phi. Now, I would like to rearrange some concepts, specifically if we're talking about this one here. I would like to, or the other way around, since we started with sine 2 twice theta here, to use a some formula for sine, let me rearrange this as well. At the same time, rearranging this to meet this standard at the top, so that these two will have the same result. So allow me to come up with this cosine twice theta, cosine twice phi, plus sine twice theta, sine twice phi. At the bottom, we have here sine twice theta, cosine twice phi, minus cosine twice theta, sine twice phi. I'll be rearranging at the top, okay? I'm gonna start with this. At the same time, I'm going to factor the negative, sine twice theta, cosine twice phi, so that this would correspond to that. And you would see that this being positive, when we factor negative, this will actually become minus cosine twice theta, this one here, cosine twice theta, sine twice phi. This now similar to that. Okay, so they will have the same identity later on, except that it has a negative sign here. Okay, so at the bottom, again, start with this to meet this form here. So you will have cosine twice theta, cosine twice phi, plus sine twice theta, that's theta, sorry. Right. And then sine twice phi. Okay. Before we continue, I would like to correct something. Actually, my notation here is incorrect. It's actually just minus. So it's just minus, okay? It's the difference. Sorry for that. It's not plus, it's the difference. My bad. I'll be changing my template for that. It will be minus. Because I notice here that the first entry is on the difference of cosine. So you have here the cosine of twice theta minus twice phi. Difference. Also true with the bottom. This is the sine difference formula, theta minus twice phi. Here, you have the negative of your sine, twice theta minus twice phi. At the bottom, again, cosine twice theta minus twice phi. Okay? And let me factor the 2. So you have your cosine twice theta minus phi, sine twice theta minus phi as well. Here, negative sine twice theta minus phi, and cosine twice theta minus phi. We're doing this because this meets the criteria of having a negative sign here. It's actually the rotation with negative here. Okay? That's negative. And take note, for rotation, the same angle here is indicated at the inside. So, simply, once you take the angle here and it fits the entire criteria, they basically take that similar angle and place it in this notation to meet our standard. Then we have here is actually the rotation of this angle twice theta minus phi. This now proven. As mentioned, I'm changing the item here. It's actually minus, not plus, because I have seen here that it's minus. Sorry for that. This is an error. So the template will be changed for that. But this is actually the proof that the product of two reflections for the specific concern in this item is actually identified as a rotation of twice the difference of the angles theta and phi. Thank you very much for watching.